Alright, so this is the solution to the 12th problem of the grind 75. This is balanced binary tree. And just a refresher, all we have to do is determine if a binary tree is balanced. And what that means is that the left and right subtrees of every node differ in height by no more than 1. So in my approach, I came up with pretty much everything that was supposed to be done, except I had an off by 1 error, and I also had, I missed an important piece of information. My logic was correct. I easily could have arrived to it faster if I had just thought through it a little bit more. In the video, I was talking just for the sake of talking. But to prevent that from happening again, let's just go right into the solution. So basically what we want to do is we're given the root and we want to find the height of its left and right subtree. That's sort of the easiest thing to do right there. So as per this example, if it's empty, then we're just going to return true, so we can have that check. If root is equal to null, then we will return true. If that's not the case, we have some sort of tree, then what we want to do is find the height between the left and the right, and we want to make sure that it is smaller than it is 1 or 0 in terms of the difference between the left and the right subtree. So what we can do is just return math.absolute, and we will get the height of the left and subtract it from the height of the right, and we will get, let's see, that's pretty much what I thought we had to do at that point, and we'll actually leave that there for now until we finish the function that we have to implement, which will be height. So I'll just make another function. It will be an integer, which will be the height, and it's going to take in a tree node, which we can just call root, and it's going to take in a count variable, which will represent the height. So if we get to the point where we have a null node, so if root is equal to null, then we are going to want to return our current count. Otherwise, what we want to return is the maximum of going all the way down the left and right paths respectively. So we will again call height on root dot left, height on root dot right. And while this seems like it would work up front, a special case that we did not consider, actually, see, I already forgot the off by 1 error. We have to make sure this difference is less than or equal to 1. It can be a maximum of 1, as per this tree right here. And while this is pretty much it, there is a test case that pretty succinctly illustrates why this is not the complete solution. So we'll switch over to the illustration. And okay, so this is the input that they gave to us, and this is the tree that it yields. If we start from the root and simply check to see if the height of the root's left subtree and the height of the root's right subtree are the same height, we would get we would say yes, they are the same height. But as per the problem description, we need to make sure that every node's subtrees, left and right subtrees, differ in height by no more than 1. And because of that, you have to actually check each node in the tree. And so we are going to pass in root.left and check that the left side is balanced, or the right side is balanced. And let me just, again, so the root's left tree has a height of 3. The root's right tree also has a height of 3. But if we go to this subtree right here, we'll see that its left subtree has a height of 2, and its right subtree right here has a height of 0. And so this would not be a balanced binary tree. And if I didn't make any simple mistakes, that should be the solution. So let's see. We'll run the test cases. Let's see. Turn. Be applied to given types. I forgot to pass in some initial counts. So 0. Those will be the well, we're treating them as roots, right? When we're getting the height of them, so we'll just set it equal to 0, and then let's run the test case. Let's see. Return math.max. We are returning an int. Again, we forgot to pass in the proper parameters. Each time we go down one more level, we want to add 1 to the count. And just going to run. That worked. And yes, that also worked. So this has been the solution to the 12th problem now in the grind 75. And this has been what? Balanced binary tree.